The Big Freeze is one of the most widely accepted theories about how the universe will end. As the universe expands, galaxies will drift farther apart, and eventually, star formation will completely stop. Over the next trillions to quadrillions of years, existing stars will burn out, leaving behind only black holes, white dwarfs, and neutron stars. Without heat or energy, the universe will grow colder and darker, until even black holes slowly evaporate due to Hawking radiation. At this stage, even atoms could decay, leaving behind nothing but a thin mist of subatomic particles. The entire universe will reach a temperature just above absolute zero, making any form of life impossible. This scenario suggests that the universe is slowly dying, with no way to reverse its fate. But could some unknown force or undiscovered physics restart the cosmos? Is the Big Freeze truly the final chapter, or is there something beyond? True or false? Dark energy plays a key role in the Big Freeze by accelerating the expansion of the universe. True. What is the primary cause of the Big Freeze? The expansion of the universe due to dark energy. Fill in the blank. The Big Freeze is a theory that describes the blank end of the universe. Cold and dark. Fill in the blank. As galaxies move farther apart, the universe will continue to blank. Expand. What will happen to stars in the Big Freeze scenario? They will slowly burn out and die. Fill in the blank. In the distant future, black holes will evaporate due to blank. Hawking radiation. True or false? The Big Freeze theory suggests that the universe will eventually stop expanding. False. The universe will continue expanding forever, eventually becoming cold and empty. Fill in the blank. In the far future, the universe's temperature will approach blank. Absolute zero. How does the Big Freeze affect black holes? They will eventually evaporate due to Hawking radiation. Fill in the blank. If dark energy continues to accelerate expansion, galaxies will become blank over time. Isolated and unreachable. True or false? The Big Freeze will occur within the next few million years. False. This process will take trillions to quadrillions of years to fully unfold. Fill in the blank. After stars die out, the last sources of energy in the universe will be blank. Evaporating black holes. What will be the final phase of the Big Freeze? The breakdown of even atoms into subatomic particles. Fill in the blank. The Big Freeze is different from the Big Crunch because it predicts that the universe will blank. Expand forever and fade into darkness. Fill in the blank. As the universe expands, the cosmic microwave background radiation will become blank. Weaker and undetectable. If the Big Freeze is the ultimate fate of the universe, what do you think could exist beyond the final stage of cosmic darkness? If the Big Freeze is correct, the universe will eventually become cold, dark, and nearly empty, with only subatomic particles scattered across vast distances. However, some scientists speculate that quantum fluctuations could create new pockets of energy or even trigger a new Big Bang. Others suggest that space-time itself might decay, leading to unknown physical phenomena. While nothing we recognize today would survive, the laws of physics might still allow for unexpected events beyond human understanding. True or false? Galaxies in the distant future will be so far apart that they will eventually become invisible to one another. True. What is the ultimate cause of the Big Freeze? The expansion of the universe due to dark energy. Fill in the blank. The energy available in the universe will become more blank over time, making it unusable. Spread out. If the universe cools at an average rate of 0.001 Kelvin per billion years, how long will it take for the universe's temperature to drop from 2.7 Kelvin to near absolute zero, 0.01 Kelvin? To calculate how long it will take for the universe to cool to near absolute zero, we use the given cooling rate of 0.001 Kelvin per billion years. Since the universe is currently at 2.7 Kelvin, it needs to cool by 2.69 Kelvin. Dividing this by the cooling rate, we find that it will take approximately 2.69 trillion years for the universe to become completely dark and cold. What will be the final objects remaining in the universe before it reaches total darkness? Black holes. If a galaxy moves away at 300 kilometers per second due to cosmic expansion, how far will it travel in 10 trillion years? To calculate the distance a galaxy will travel due to cosmic expansion, we use the formula distance equals speed multiplied by time. The galaxy is moving at 300 kilometers per second, and we need to calculate its distance over 10 trillion years. First, we convert 10 trillion years into seconds, which gives us 3.15 times 10 to the 20 seconds. Multiplying this by 300 kilometers per second, we get a final distance of 94.5 sextillion kilometers, showing just how vast the universe will become. True or false? The big freeze will happen when all galaxies collapse into black holes. False. Instead of collapsing, galaxies will move apart, and black holes will eventually evaporate. Fill in the blank. In the far future, the last sources of heat will come from blank. Decaying particles and evaporating black holes. In the distant future, when all stars have burned out, what will happen to the remaining matter? It will decay into fundamental particles. Fill in the blank. The universe's temperature will approach absolute zero as blank decreases. Cosmic microwave background radiation. True or false? As the universe expands, the total amount of energy in the universe is increasing. False. The total amount of energy stays the same, but it becomes more spread out and less useful over time. Fill in the blank. Scientists predict that after all energy is lost, the universe will contain mostly blank. Weakly interacting particles. Which of the following events will happen first in the timeline of the Big Freeze? Stars burning out. If the universe expands by 1 billion light years in 5 billion years, what is the average speed of expansion in kilometers per second? To calculate the speed of the universe's expansion, we divide the total expansion distance by the time. The universe expands by 1 billion light years over 5 billion years, which equals 9.46 times 10 to the 21 kilometers. Converting years into seconds, we get 1.575 times 10 to the 17 seconds. Dividing these values, we find that the expansion rate is an astonishing 60,000 kilometers per second. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun learning today. Don't forget to like, subscribe, and hit the bell so you never miss a new quiz. See you next time, Brainy Friends.